let's get straight into sound waves. So let's begin. So what exactly is a sound wave? Remember the difference between mechanical and electromagnetic waves. A mechanical wave needs a medium, so it needs to be in a solid, a liquid, or gas. It needs particles around it in order to have that wave happen. So a sound wave is a type of mechanical wave, and it travels slowest through gas and fastest through solids. Okay. It's also a longitudinal wave, so it goes in the same direction as the force of motion. So as the particles are moving, it's going the same direction as the source of the movement. Okay. So sound waves can be reflected, it can be absorbed, transmitted, and even diffracted. So if sound waves hit smooth waves like concrete, or smooth objects like concrete, most of the energy is reflected back, which is what creates an echo. So if it's smooth, solid obstructions or objects, most of the energy of that sound wave is reflected back, which is why we hear an echo in places such as like empty buildings that have concrete all over and no other objects to absorb the sound wave. If it hits porous walls, like in theaters or in recording studios, most of the energy there is absorbed, which is why people can't hear outside of a recording studio. Or if you go in a movie theater, you don't hear the sounds as loud as if you were in the movie theater. Okay. You could also sometimes hear people in another room. So if I was in my kitchen and someone else was talking in my room, that's because the waves are being diffracted. So they're moving around the obstruction in order for me to hear it. So again, it could be reflected, absorbed, transmitted, and even diffracted. Okay. So let's talk about factors that affect the speed of sound. First, let's talk about stiffness. Stiffness is just how rigid a object is. So like a metal is more stiff than a cotton ball, or a piece of plastic is more stiff than pudding, or something like that. Okay. So sounds travel faster in stiffer mediums such as solids. And they also travel faster in more rigid solids like metals compared to, again, cotton balls or pudding. So they travel fastest in solids compared to gas because solids are more stiff. Okay, and this all depends on how densely packed the molecules are in that matter. So if I have one solid that the sound is traveling faster through, that's because the molecules are more densely packed than another one where it's traveling slower. Okay. And again, if there's no medium, no sound travels, that's because it's a mechanical wave. Another factor that affects the speed of sound is density. Density is how much matter is given in an amount of space. Okay, so it's opposite of stiffness. So as density increases, the speed decreases. As stiffness increases, speed increases. Okay, so that's just something to remember. Stiffness up, density down. Okay, so more density means there's more mass, so there's more stuff there. So sound is traveling more slowly through that stuff, through that mass. Okay. Next is temperature. So temperatures fluctuates between solids and liquids. So with an increased temperature in a solid, so for example, if I heated up a cup, just a cup, not with anything in it, that will decrease the speed because it's reducing the stiffness, because molecules are able to be more fluid when the temperatures are increases in solids. In fluids, the increased temperature reduces the density, so the sound speed increases. Okay, so fluids, it reduces density, so the speed increases. Solids, it reduces stiffness, so the speed decreases. Okay, So in solids, the density is going to stay the same. It's just reducing the stiffness. In fluids, the density is lowering, so the speed is increasing. Okay? So again, temperature for solids, as temperature increases, so does the sound speed. The sound speed decreases. For fluids, as temperature increases, the speed increases. Okay? Solids, as temperature increases, speed decreases. Fluids, increase temperature, increase speed. Next is loudness. So loudness just means the perception or the awareness of energy of the sound. Okay, so if we look at this one right here, we see that a soft high note versus a loud high note, we could see there's much more amplitude in the wavelength, meaning that it will be louder. Okay, so again, a soft low note has a small amplitude than a loud low note. Okay. So again, loudness is just the perception or awareness of the energy of a sound. Then we talk about intensity. Intensity is the amount of energy a sound wave carries per second in a given area. Okay, so just how intense that sound wave carries. And it all has to do with energy. So if there's a closer sound, there's greater energy being released and intensity. So with greater energy, there's greater intensity. And with greater amplitude, so how high that wavelength is going, there is a greater energy or intensity. Okay? So it's going up more. We see, oh, that's going high. It's more energy. Okay? Now let's talk about how we measure loudness. Again, that's just how we measure, how we see how loud a sound is. We measure it by decibels. That's the unit that's used to measure the loudness. And just a fact, sounds louder than 100 decibels can cause damage to our ears. So what exactly can cause that damage? If we look, a hairdryer and a rock concert, those are it's right in between those two. So a little above a hairdryer, a little below a rock concert can damage our ears. So it's important to protect them. Make sure our AirPods or our headphones are at the appropriate volume, because as we see as an iPod at peak volume, it's way above the loudness that can cause damage to our ears. Okay. Next is pitch. So pitch is just how high or low a sound seems. Like a low C note versus a high A note. Okay. Pitch is determined by frequency. So with a high frequency, there's a high pitch. So if there's a lot of wavelengths in a given time period, that's a high pitch. If there's not as many frequencies, or not as many wavelengths in a certain amount of time, that's a lower pitch. We can see this here. The thickest guitar string is the lowest note, and the highest one is the highest note. And as we see it going up in the GIF, we could see that there's more wavelength in between the GIFs. And lastly, let's talk about the Doppler effect. The Doppler effect is a change in frequency, which means there's going to be a change in pitch, of the sound waves from a moving object in relation to an observer. So if you ever heard a police siren or a ambulance siren, or even a train or just a car just moving by, you could kind of hear that the sound sounds higher when you are not passing it, and as it passes, it gets lower. That's because of the Doppler effect. Okay, so it goes like meow. The higher frequency is before it passes you, and the lower frequency is after it passes you. So it might sound higher than it is before it gets to you, and then after it passes you, it sounds lower than it actually is. Okay. So that was it for our lesson on sound waves. I hope you learned something new, and I will see you next time.